In this lesson, we're going to look at different representations of functions. Our learning target is, I will be able to represent a function in multiple ways: equations, tables, and graphs. We're also going to evaluate a few of the equations or functions that we have written. So in this first example, we're given several scenarios and we're asked to write a function rule or equation for each scenario. Let the output equal y and the input equal x. Part A, the output is 8 more than the input. So we're going to look at those words very closely, and then we're going to translate those words into an equation. We're already told in the directions that we're going to let the output be y. So in this first example here, we're going to go ahead and write it as the output is, so that could be written as y equals 8 more than the input. Whenever you're talking about 8 more than something, think mathematical operation of adding. So if the input is going to be represented with an x, I'm going to write it as y equals x plus 8. And then reread it one more time just to make sure that it makes sense. The output is 8 more than the input. So y equals x plus 8. I believe we could also write it as y equals 8 plus x. Okay, on the next example, it says the output is 4 times the input. So once again, since we're calling the output y and it says the output is, I'm going to start it with y equals 4 times the input. The word times means multiplication, and the input is x, so I'm going to write this as 4x, because we know that when we have a variable and a number right next to each other, that the operation is multiplication. In example 2, we're given an equation and we're asked to evaluate this equation when given certain values for x. So we are given 2 different values. We're given when x equals 2 and when x equals -3. So all we have to do is actually substitute both of these values into the original equation. So I'm going to have this as 2 separate problems. First, let's evaluate when x equals 2. So I'm going to rewrite the equation and I'm going to substitute the x with a 2 because that's the first value that we're given. So we have -2 times 2 plus 7. I know that multiplication comes before addition, so -2 times 2 is -4. And then when I add the -4 and the 7 together, I get y is equal to +3. So I just evaluated that equation when x was 2. Now, technically, I could write it as an ordered pair if I were to graph this equation, and I would say 2, 3, because when the input is 2, the output is 3. So written as an xy coordinate, it's 2, 3. Now let's do the same thing, but this time we're going to evaluate when x is equal to -3. So I'm going to substitute that value into the equation in the place of x, except this time I'm told to substitute the x with a -3. So I'm using the same equation, but I'm plugging in a different value for x. So once again, I'm going to follow order of operations. -2 times -3, that is a +6. And then I'm going to add the 7, and I get y equals 13. Again, if I wanted to, I could write this as an ordered pair to this function or to this solution, or a solution to this function. And the way that I would write that would be -3, 13. What I'm saying is when my input is -3 in this equation, my output is 13. I also, if I wanted to, I could put it as a table of values and then just solve for y. So in other words, when I figured out, or when I was given the fact that x was 2, y was equal to 3, And when I substituted an x with a -3, I got y equals 13. So I just want you to see that you can write these answers in multiple different formats.